The last section of the last video for section 5.1 is going to be on logarithmic differentiation. So this is a great technique for taking the derivative of complicated functions that don't necessarily involve logarithms, but we can use the powers of logarithms to make the derivatives easier. So let me work through a fairly easy example, and then I'm going to come back and tell you step by step what we've done. So let's say we want to differentiate the function y equals x to the x power. The first thing we're going to do is take natural log of both sides. So even though the original problem did not have logarithms, I'm going to take the natural log of both sides. So I have natural log of y equals natural log of x to the x. And now I'm going to simplify the right-hand side using rules of logarithms. So I can take this exponent of x and bring it down as a coefficient. So natural log of y is the same as x log x. Next, I'm going to take the derivative of both sides using the chain rule. So I'm going to take the derivative of both sides with respect to x using the chain rule. On the right side, I'll also have to use the product rule. So on the left, I'm taking the derivative with respect to x of log of y, which is 1 over y times y prime, so y prime over y. On the right side, using the product rule, it'll be the derivative of the first times the second, plus the first times the derivative of the second. So 1 log x plus x times 1 over x. So in other words, y prime over y is equal to natural log of x plus 1. And now we're almost done. Remember that what we're trying to find is the derivative, which is this y prime. So we can solve for y prime by multiplying both sides by y. We get y prime equals y times natural log x plus 1. And then we can finish by substituting in that y is the same as x to the x. So y prime equals x to the x times natural log x plus 1. And that's my final answer. Now let's look at what we did. First of all, we took natural log of both sides. So that was this step right here. We can change colors. So as our first step, we took natural log of both sides. And then we expanded the right side. So I'm using RHS for right-hand side. We expanded the right-hand side of this equation using properties of logarithms. So here where I used the power rule to expand, that was step 2. For step 3, differentiate using the chain rule. The reason I'm saying to use the chain rule on both sides is to remind you that the derivative of natural log of y is y prime over y. So step 3 started here and continued down to about here. In step 4, we multiply both sides by y, so this y comes from the denominator on the left up to the numerator on the right. And then we replaced y with the original function. So where I had a y, I replaced it with x to the x. So this is an example of using logarithmic differentiation. Now let's look at one from the textbook, which is going to be a little bit more involved. This is going to be problem number 78. The function we're given is y equals the square root of x squared minus 1 over x squared plus 1. And we probably want to go ahead and think about this as being x squared minus 1 over x squared plus 1 to the half power. So for our first step, we're going to take natural log of both sides. Natural log of y is natural log of x squared minus 1 over x squared plus 1 to the 1/2 power. And then we're going to expand the right side using properties of logarithms. So first of all, let me use the power rule, which means I can bring this 1/2 down as a coefficient. And then I can use the quotient rule to expand this quotient as a difference. Notice my parentheses here. It'll be 1/2 of natural log of the numerator minus natural log of the denominator. And then I'm going to choose to go ahead and distribute this 1/2. So I have 1/2 natural log of x squared minus 1 minus 1/2 natural log of x squared plus 1. And remember, this represents natural log of y. So let me just box this for a moment. This is the result of step 2. Now for step 3, I'm going to differentiate, making sure that I'm using the chain rule everywhere I need to. So I'm going to take d by dx of the left side and d by dx of the right side. On the left side, the derivative with respect to x of log y is y prime over y. On the right side, I'll have 1/2. The derivative of natural log of x squared minus 1 is 1 over x squared minus 1 times the derivative of the inside. So I get a 2x on top. Minus 1/2. The derivative of natural log of x squared plus 1. Again, the derivative is going to be of the form u prime over u. So I move my u, x squared plus 1, to the denominator, and I multiply by the derivative of the inside, which is 2x. Now notice I have 2's canceling in each fraction. So y prime over y is equal to x over x squared minus 1 minus x over x squared plus 1. And that's the end of step 3. Coming back to the top. Step 4 is to multiply both sides by y. I'm kind of sad that I just erased this. Let me rewrite my original problem down. Okay. Coming down to step 4, I'm going to multiply both sides by y in order to isolate the y prime. So y prime will be y times x over x squared minus 1 minus x over x squared plus 1. And then I replace y with the original function. That's why I copied this back again. The square root of x squared minus 1 over x squared plus 1 times x over x squared minus 1 minus x over x squared plus 1. Now we could go further, just doing more algebra, but I'm going to stop there because we've illustrated the technique of logarithmic differentiation. So remember, with logarithmic differentiation, the original problem does not contain any logarithms, but you put them in there in order to make it easier to take the derivative.